In this video, we will be outlining the recovery module of your space race project. So what a recovery system is, what its goal is, and how to do that most effectively. Okay. So what is the purpose of a recovery system? All right. The purpose of your recovery system is to slow down your rocket enough so that when it hits the ground, it does not end in a crash. One of the most common ones that you see is a parachute. Most of the rockets that we have used up until this point when they re-enter, use parachutes to slow them down. So how does a recovery system work? When we look at a recovery system, we're looking at, again, all of the different forces that are at play on your rocket. However, instead of looking at the launch, we're now looking at its descent back to the ground. Okay, so rather than looking at the propulsion force from your rocket, we're now looking at gravity, and we need to figure out a way to oppose gravity, right? And so in order to do this, we will be using drag again. Okay, so just like we did in the body unit, we'll be calculating drag, except for this time, instead of trying to minimize drag, we will be trying to maximize it to then oppose the force of gravity. So maximizing drag. We talked about in the body unit that in order to minimize drag, you need to decrease the surface area. And this time, we will be trying to maximize the surface area. Okay, so a parachute is a large cloth circle that is trying to maximize the surface area in contact with the air around it. Okay, and what that's going to do is going to increase the drag, and therefore you will have less of a force of gravity pulling you to the ground. Okay, so again, your drag calculation is going to be friction equals mu times the normal force, right? And just as a reminder, your mu for this is your air friction coefficient for 25 degrees Celsius, okay? So this is a pretty short module, okay? It should be one of the easier ones, especially since we've mostly covered all of the different aspects again within this module. So the first thing you're going to need to do is create a digital design for your recovery mechanism, okay? Again, I need to know the dimensions, materials list, and assembly procedure so that you can include those things in your infographic. The second thing I need you to do is draw a free body diagram for all of the forces acting on your rocket during descent. Right? I need to see how gravity is going to be minimized in order to get your rocket safely back to the ground. Third, I need you to calculate the net force experienced on your rocket on its descent. You'll be needing to use things like mass, surface area, and then the friction equation to figure that out. Okay? So this is the last module. And so after this, the only thing you will have left for this project is to assemble your infographic. And if you've been doing a good job of assembling all of your free body diagrams, directions, and calculations, then that last step should be very easy. It will be just compiling and formatting into a professional looking infographic. So with that all in mind, good luck building, and we'll see you in class.